All right, good afternoon.
Good afternoon.
Interesting day.
Yeah.
For sure. So same as yesterday. Yesterday we used the slope formula. What was the slope formula?
Y divided by x2 minus x.
All right. So we used the slope formula, and we realized that if we had a slope and a point, then we could also create a second point and actually write an equation using that secondary point, just x and y. All right, and that was actually really cool. I think probably one of the coolest things I've ever learned. Right. Never done it that way, but it works well. So we're gonna do that same thing today, where we're writing an equation of a line, but that line now is going to be parallel or perpendicular, okay, to a given line. And so we need to recall what it means to have parallel lines. How do you know two lines are parallel? They never touch. That's true, but they have the same slopes. A lot of times if we were to use mathematical notation, we would say M1 is equal to M2, where M sub 1 represents the slope of the first line, and M sub 2 represents the slope of the second line. So if you're into equations and notation, then that's the way to go. What do you know about perpendicular lines? Close. Opposite reciprocal slopes, yes. Opposite reciprocal slopes. And so opposite refers to change the sign, and then reciprocal flips the fraction. One should be positive, one should be negative, and their fractions are flipped. So the mathematical way to write that, if they were just reciprocals, when you multiply reciprocals like 2/3 times 3/2, what do you end up getting? You get 1. Well, for them to be opposite reciprocals, when you multiply the slopes together, you'll actually get -1, okay, to be opposite reciprocals. So these are not perpendicular slopes. Give me an example of two perpendicular slopes. 2x, or sorry, 2, let's do 2/3, and then what would the second slope be? -3/2. Good. And so you can see if we actually try this little equation, the product of the slopes becomes -6/6, which does in fact reduce to -1. So the product of the slopes equals -1. That's the mathematical definition of opposite reciprocals. But usually we just say the words opposite reciprocal, change the sign, flip the fraction. And with that knowledge, then we can go about writing lots and lots of equations today. Which will probably take you all of 10 minutes again. I didn't realize I could save a day. All right. Example 1, determine if lines are parallel or perpendicular. What form are these lines in? Standard form. Standard form where the x and the y are on the same side. So how are we going to figure out if these lines are parallel or perpendicular? Put it into slope-intercept form? All right, we can do that. Put into slope-intercept form. Maybe. So slope-intercept form is y equals mx plus b. All right, well, we can do that. Let's see if we can do that with the first one here. So 2x minus y equals 4. And if I want to put it in slope-intercept form, what can I do? Nice. Add the y to the other side. Can you do that? Oh, yeah. And so we're going to move that y over. And then we want to move the 4 also, right? So 2x minus 4 equals y. Okay, that was good. So what's the slope of this first line? Okay. So the slope of the first line, so I'm going to call it m sub 1. M sub 1 is equal to 2. And then if I wanted to do that for the second line, 4x minus 2y equals negative 4. All right, so maybe Swapatuli again. Yeah, a little Swapatuli there. So I have 4x, I know, what math teacher says Swapatuli? Mrs. G. Okay. And then what do we need to do? Divide by 2. Everywhere. Okay. So we get 2x plus 2 for our equation in slope-intercept form, which means the slope of the second line is 2. And so what do we conclude? Parallel. Okay. So do you know what these 3 dots mean? Therefore, have I not done that in this class?
Nope.
Oh, well, okay. Welcome to higher math. These 3 dots are the shorthand. You know, you in high school, you used to take a class called dictation. This would be years ago now. Dictation, where you learned shorthand notation. So this means therefore parallel. All right. 3 dots and a triangle means therefore. Yep. All right. Okay.
So those 3 dots mean therefore parallel, not just there.
No, it means therefore.
Oh, okay.
Yeah. Therefore, we have parallel lines.
Oh, I see.
Sorry. Okay.
Yeah.
So let me ask you another question. This is also in standard form. This seemed like too much work for me. Is there a faster way? I mean, you can always do this.
You can just look at what's on
So how do you, what's on the x? Wait a minute. What's on the x here is 4. That wasn't the slope.
But you can see that it's divided by 2.
Oh, so you have to divide it by the number in front of the y.
Oh,
So if you're in ax plus by equals c form, how do you find this slope? So what do you have? Like, we can't just use 4. What did we have to do with the 4? We had to move it, didn't we?
Well, we lived 2 y.
Well, okay, yes, but we could have moved that as well. All right. So we would move the a over to the other side, and then we would divide it by b. Yeah. So, and actually, when you're in standard form, if you wanted to find the slope, it's just the opposite of the a value divided by the b value. Okay. So with that knowledge, our a is 1 and our b is 2. What's the slope of this line? Negative 1 over 2. Very good. And here our a is 4 and our b is negative 2. So what's the slope of the second line? How did you get that? The opposite of a divided by b. So negative 4 divided by negative 2 turns out to be 2. All right, what are those slopes? How do you know they're perpendicular? Opposite reciprocal slopes. Therefore, perpendicular lines. Boy, I really like this shortcut method, right? Yeah. Okay, but again, you know, I don't like having you memorize stuff, and that seems like a factoid thing, like just memorize it. Whereas this is, you know, isolating y is a great way to get the slope. You know, when in doubt, go with what you know. Okay, but that's kind of nice. All right, so therefore, perpendicular lines, they're opposite. One is negative, one is positive, and reciprocal. You could also check the product. What should their product be? Negative 1. Yes, very good. All right, example 2. Write the equation of the line that meets the conditions. Express the results in standard form. Write the equation of line that meets the conditions. Express the result in standard form. So when there's a fire, the AC, whenever there's a fire drill impact, the AC automatically shuts off. And yeah, I sent him a note. Hey, I think they're turned off. But okay.
So the fire alarm goes off twice, and they're like, "Oh, no, just in case we're calling a fire alarm," and then it's actually a fire.
Yeah.
And so that just shows like how bad this could be
the
holy
voice
fire
that
alarms.
already goes.
Yeah, well, I mean, anytime you drill something too much. Now, I will say it was good to have a fire drill during lunch, because did you know what to do if you had a fire drill during lunch?
I didn't know where my class goes. I literally just stood there, me and the boys were just like talking, and we're like, alright, let's just walk around like.
Well, every time we have a fire drill, it's always in the same class. It's always in third period or fifth period.
It's supposed to, they rotate them.
I wish you do it every single class.
Yeah, like I have no idea. Oh, I do know.
I also think that we should practice lots of rules. We barely.
Yeah, we don't practice that.
One hard lockdown and one soft lockdown. Alright, anyway, kind of interesting. Yeah, I had to text our esteemed principal. I got my phone, I was like, no, there's smoke in the top of 3. It's a real drill, real fire. Yeah, so.
Yeah, someone just
Yeah.
There's a
just
picture
sounds
of
like a
Mr.
great
Paul
idea.
staring at it because they said go back to class and they said yeah, we just like a picture of Paul staring at this.
Okay. Alright, so we want to write the equation of the line that has this point in it. But it needs to be parallel to this line. So what do we need in order to write the equation of a line? The slope. We need the slope. And so since we want a parallel line, we need the same slope as this line. What's the slope of this line? -3. So we could rewrite this if we wanted to. Y equals -3x plus 1. So the slope is -3. So we want to use the same slope. So the slope of a parallel line, do you know that symbol?
Yes.
Yes, you've seen that before, parallel lines?
Yes.
No, this would be perpendicular. Yeah, okay. All right. Oh no, so a parallel slope is going to have the same slope. We want it to pass through this point, -2, 1. And I'm trying to write an equation, so I'm going to use the same technique as yesterday, an equation for any generic point, x and y. And so then I'm going to just use my slope formula. So slope equals y2 minus y1 over x2 minus a -2. Are you good with that? That's what we did yesterday, right? And then I'm going to just make that -3 over 1. And we can do what? Cross multiply. So -3 times my denominator is going to give me? Good. And then 1 times my numerator? Good. And then write the result in standard form. So ax plus by equals c. So x's and y's on the same side. All right. So I'm going to do what?
Add 6 and subtract.
Add the 6 and subtract the y. So -3x minus y equals? +5. Very good. Is this standard form or not? No. What's wrong with this? There's a negative in front. That a term must be positive. So yeah, so you can multiply or divide by everything by -1. So that becomes +3x, y equal to -5. So that is the official standard form.
The 3x.
Yeah.
Yes. 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 I'm sorry? I don't know. Has the book told us to?
Just because.
The manipulation wise, I have to say it's kind of good. Standard form is quite easy to grab, just plugging in zeros. So it's a good form to be in.
So are we just gonna leave it like this?
All right. Over here, again, we want our line to pass through this point. The downfall, I guess, actually, the downfall of standard form is that you can't graph this on your calculators. So, like, I can graph this equation on my calculator, and if I put y equals negative 3x minus 5 on my calculator, I can see that they're going to be parallel. You can actually check to see that it passes through the point negative 2, 1. So, you know, slope-intercept form is useful for checking on our calculators. Okay. So keep that in mind. But they did ask for standard form. All right, so we want to be perpendicular to this line. So how do we figure out the slope of this line? Whoops. Huh. That's why they're calling me. All right. I always worry about those calls because I'm like, uh-oh, what kid's injured?
Which one
No,
is
my
this
parents
time?
just look at it and they're like, I sure hope he's dead.
Oh my
Oh.
God.
All right. So
Like,
if we want to use the shortcut with the opposite of a over b, so that's going to be negative 3 over negative 1. So we get the slope of positive 3. But we need what kind of slope? Yeah, we want a perpendicular slope, so that's going to be what? Negative 1/3, opposite reciprocal. It's going to pass through the point to negative 5, and I want a generic equation that gives me any ordered pair xy. Okay, so again, my slope is going to equal y2 minus y1 over x2 minus x1. Where does this negative go? Can you put it with the top and the bottom? Not and, but yeah. One or the other. Okay. It doesn't technically matter. I put it with the numerator usually. Either or.
Is it negative 1/3?
Yes. Yes. Opposite reciprocal. So change the sign, flip your fraction. Yeah. All right. So I'm going to take my denominator times negative 1, which gives me what? And then I'm going to do 3 times my numerator, and that's going to give me good. And, well, now I'm going to do it the other way since y'all said that. So I'm going to swap my x to the other side and move the 15 away. So that's going to give me negative 13 positive x. Is it okay to write it like that? Equal sign is, we can flip around how we want. Okay. Yeah? Yeah. So I'm okay with that being standard form. Okay, any questions for me?
No. Yeah, that's one more.
All right, have at it.